Welcome to ION Prep Test. We shall discuss the detailed solutions of Benchmark Exam 1, Mathematics 12 PCM. Question number 1. If Z is a complex number satisfying the condition mod of Z minus of 4 plus 3i less than or equal to 3, then the product of the least and greatest values of mod Z is option A 9, option B 12, option C 6 and option D 16. The answer is D. This mod of Z minus 4 plus 3i less than or equal to 3 represents set of all Z which lie inside or on the circle with the center as 4, 3 and the radius as 3. As you can see from the figure that 4, 3 is the center and the radius is 3, therefore the circle should be touching the x-axis, and you can find that the point A is nearest from origin within the locus and point B is farthest from origin. So what we want is OA into OB, but OA is nothing but OC minus AC, and that is 5 minus 3, that's 2. Greatest value of mod Z will be OB, and that is equal to OC plus CB, that is 8. Now the product of least and greatest values, as we can see, is 2 into 8. We know that mod Z represents the distance from origin to the complex number Z. So when we wanted the product of the least and greatest values, it was 2 into 8. So the answer is 16. Now we have an alternative method using geometry. We know that from geometry, pure geometry, OA into OB is equal to OD square, that is length of the tangent, square of the length of the tangent. And you can see that the length of the tangent is 4 units. So therefore OA into OB would have been 4 square, and that is equal to 16. Okay, we can go for the second method. We are given that mod of Z minus 4 plus 3i is less than or equal to 3. Therefore mod Z minus mod of 4 plus 3i is less than or equal to 3, or modulus of 4 plus 3i minus mod Z is less than or equal to 3. That is, 3 is greater than or equal to mod Z minus 5 or 5 minus mod Z. So mod Z is less than or equal to 8 and mod Z is greater than or equal to 2. So the least value of mod Z would be 2 and the greatest value of mod Z is 8. Therefore the least value of mod Z into greatest value of mod Z is 2 into 8. We have here used the triangular inequality, that is mod of Z1 minus Z2 is greater than or equal to mod of mod Z1 minus mod Z2. Therefore the answer for this question is D, and that is 16. Question number 2. If the matrix A is equal to cos theta sin theta minus sin theta cos theta, and matrix B is equal to 1 0 1 1, comma, A transpose denotes the transpose of A, and P is equal to AB A transpose, and if f of n is equal to A transpose multiplied by P power n into A, then f of 100 is equal to, first option A 100 101, second option 1001, third option 100 01, fourth option 101. The answer for this is D. Now we consider A. Observe that first of all this A is an orthogonal matrix, that is A transpose into A is equal to identity matrix. Now coming back to f of 100, what is that? It will be A transpose into P power 100 into A. So that makes it A transpose into P multiplied 100 times A. But what is P? Let's get back. What is P? That is AB A transpose. So AB A transpose multiplied 100 times. But as you can observe by associativity, you can keep clubbing A transpose A, and then you will be left with B terms 100 times, and A transpose A is simply I Therefore, we get b power 100. Hence, f of 100 is nothing but b power 100. As you can see, b square is 1021, b cube is equal to 1031, b power 4 is equal to 1041. Similarly, by mathematical induction, you can show that b power 100 is equal to 10101. Now, let's look at the shortcut method. Theta is not given in the choices, so we can substitute some value for theta, and the answer being independent of theta, what we can do is we can put theta equal to 0, then A becomes 1001, which is nothing but the identity matrix, and P simply becomes B. Therefore, f of 100 would be A transpose into b power 100 into A, which is nothing but I into b power 100 into I, and which is nothing but b power 100. And as we have seen, b power 100 is nothing but 10101 as in the first method. Therefore, as you can see, the answer is D. Third question, let f be a function from R2 closed interval 1 comma infinity be a function defined by f of x is equal to x square plus x sin x plus cos x. Then f is, first option, 1 1 but not onto, second option, onto but not 1 1, third option, 1 1 and onto, fourth option, neither 1 1 nor onto. The answer for this question is B. Given f of x is equal to x square plus x sin x plus cos x, f dash of x is equal to 2x plus x cos x plus sin x minus sin x, that is equal to x into 2 plus cos x. Clearly, 2 plus cos x is a positive quantity because cos x lies between minus 1 and 1. And now the sign pattern of f dash of x depends only on x. F dash of x is negative up to 0 and positive from 0 onwards. So f dash of x changes sign in the domain of f, and it's clearly a many to one function, so it cannot be 1 1 function, as you can see. And one more thing, f has a minimum at x equal to 0 and the value of that minimum value is 1, as you can see from the figure. So f of x is greater than or equal to 1, but the range of f will be from 1 to infinity. The reason being, f is a continuous function, so whenever it takes a value, the least value is 1, and it will take all the values from 1 to infinity. So the range of the function is 1 to infinity, which is the codomain of the function given. Range is equal to the codomain, hence the function is onto. As we have already seen that the function is not a 1 1 function, therefore the function is onto but not 1 1. Let's move on to the question number 4. Let P be a relation defined on the set of all real numbers R such that P is equal to set of all ordered pairs A comma B such that cos square A plus sin square B is equal to 1. Then P is, first option, an equivalence relation, second, reflexive and symmetric but not transitive, third, reflexive and transitive but not symmetric, fourth option, symmetric and transitive but not reflexive. The answer is A. Let's see how it goes. For a relation to be equivalence relation, it has to be reflexive, symmetric and transitive. So let us verify that it is reflexive relation. For a relation to be reflexive, every element of that set must be related to itself. So let us see if A comma A belongs to the relation P. Now if A comma A is to belong to the relation P, it would happen if and only if cos square A plus sin square A is 1. That is, we replaced B with A, and we are seeing that it is possible to have cos square A plus sin square A is 1, which is already a true equation. So hence P is reflexive. Now for symmetry, whenever A comma B belongs to P, we have to show that B comma A also belongs to P. Now let us see that whenever A comma B belongs to P, cos square A plus sin square B is 1. So that makes it cos square A we are writing it as 1 minus sine square A, and plus sine square B we can write it as 1 minus cos square B, and we get cos square B plus sine square A equal to 1. The roles of A and B have been reversed, so it means that B comma A belongs to P. So whenever A comma B belongs to P, we have shown that B comma A also belongs to P. Hence, symmetry has been established. Now, the transitivity, whenever A comma B belongs to P and B comma C belongs to P, we have to show that A comma C also belongs to P, and the steps go this way. Cos square A plus sine square B is 1, and cos square B plus sine square C is 1. That is, A comma B belongs to P would imply the first equation, and B comma C belongs to the P would imply the second equation. If you added the two equations, we get cos square A plus sine square B plus cos square B plus sine square C equal to 2, and that gives us cos square A plus 1 plus sine square C is equal to 2, which gives me cos square A plus sine square C is equal to 1, which in turn tells us that A comma C belongs to P. Hence, the relation P is transitive as well. We have already shown that P is reflexive, symmetric. Now we have shown P is transitive. Hence, the relation is an equivalence relation. Therefore, the answer is, it is an equivalence relation. Let's move on to the question number 5. If A be a set such that the number of subsets of A is equal to the sum of the coefficients of the expansion 1 plus 3x square minus 2x cube raised to the power 5, then the number of elements in A is, first option 32, second option 16, third option 31, and fourth option 5. The answer is D. Let's explain how it goes. The sum of the coefficients of a polynomial is obtained by putting x equal to 1. So as you can see, when x is equal to 1, 1 plus 3x square minus 2x cube raised to the power 5 becomes 2 power 5. Therefore, the sum of the coefficients in that expansion would be 2 power 5. Now, let A be having the number of elements to be n. Then the number of subsets of A will be 2 power n. That's a formula. That is 2 raised to the number of elements of a set will give us the number of subsets of that set. So 2 power n happens to be equal to 2 power 5. Therefore, n has to be equal to 5. Hence, the number of elements of A is 5. Therefore, the answer is D. Let's move to the next question, question number 6. Let AI minus BI be equal to 10 for I ranging from 1 to 3 so on up to n, and sigma AA and M capital MA denote the standard deviation and the mean deviation about mean respectively of the numbers A1, A2, so on an. Let sigma B and MB denote the standard deviation and mean deviation about mean respectively of the numbers B1, B2, B3, Bn. Then, which of the following is true? First option, sigma A is equal to sigma B, capital MA is equal to capital MB. Second option, sigma A is not equal to sigma B, MA is equal to MB. Third option, sigma A is equal to sigma B, but MA is not equal to MB. Fourth option, sigma A is not equal to sigma B and capital MA is not equal to capital MB. The answer is A. Actually, the standard deviation and mean deviation about mean are unaffected by the change of origin. It is based upon that concept. Observe that AI minus BI is given to be 10. Therefore, AI is equal to BI plus 10. So, when you go for the mean of AI distribution and mean of BI distribution, A bar is the mean. We find that A bar and B bar differ by 10. So, A bar is equal to B bar plus 10. Therefore, AI minus A bar will be BI plus 10 minus B bar plus 10. So, that gives us BI minus B bar. Therefore, sigma A is equal to under root of sigma AI minus A bar whole square divided by n, and sigma B is equal to under root of sigma bi minus b bar whole square by n. We have already seen that ai minus a bar is same as bi minus b bar. So therefore, sigma ai minus a bar whole square and sigma bi minus b bar whole square match, and sigma a will be equal to sigma b. Moreover, capital MA is also equal to MB. Therefore, the right option is sigma A is equal to sigma B, that is the standard deviation of the A series is equal to standard deviation of the B series, and the mean deviation about mean for both the series is also the same. This is, I said, is based on the concept of the mean deviation about mean and standard deviation are both unaffected by change of origin. Let's move to the next question, question number 7. If a value of c for which the Rolle's theorem holds for the function f of x is equal to 2x cubed plus ax square plus bx in the interval, closed interval, minus 1 comma 1 is half, then the point a comma b lies on the line y equal to minus x minus 1, that's the first option. Second option, b y equal to 2x minus 1. Third option, y equal to 2x plus 1, and fourth option, y equal to minus 2x minus 1. The answer is D. Let's explain how it goes. Given f of x is equal to 2x cubed plus ax square plus bx. So f dash of x becomes 6x square plus 2ax plus b. Now for the function to be satisfying the Rolle's theorem, we need f of minus 1 to be same as f of 1, and the point where the Rolle's theorem holds, that is c, f dash of c must be 0. So f dash of half is 0. F of minus 1 is equal to f of 1 will give us b to be equal to minus 2. A simple calculation will give us in 2 steps, as you can see. And f dash of half is equal to 0 gives us 3 by 2 plus a plus b is equal to 0. Therefore, now substituting the value of b equal to minus 2. So we get here the value of a also. So a value is equal to half. Therefore, the point a comma b becomes half comma minus 2. And from the options, we can see that it lies on the line y equal to minus 2x minus 1. That is, if you substitute the point half comma minus 2 in looking at the options, it is the fourth option that comes out to be correct, and therefore the right option is D. Let's move to the question number 8. If the function f of x, ax cubed plus bx square plus cx plus d has local extrema at 2 points of opposite signs, then the roots of the equation ax square plus bx plus c equal to 0 are, first option, imaginary but not purely imaginary. Second option, purely imaginary. Third option, real and distinct. Fourth option, real and equal. Let's look at the solution. The answer is C. Given f of x is equal to ax cubed plus bx square plus cx plus d, f dash of x is equal to 3ax square plus 2bx plus c. It is given that f of x has local extrema at 2 points of opposite signs. Let us say 2 points are alpha and beta. Since they are given to be of opposite signs, alpha into beta has to be negative. And at the points of extremum, we know that either the derivative has to be 0 or the derivative should not be existing. But since the function is a differentiable function, the derivative has to be 0. F dash of alpha has to be equal to 0 and f dash of beta has to be 0. Therefore, that implies alpha and beta are the roots of the equation f dash of x equal to 0, and the product of the roots, as you can see, has to be c by 3a, and alpha into beta has to be negative. Therefore, c by 3a must be negative. Therefore, c and a must be of opposite signs. A into c is less than 0. Now, the discriminant of the equation ax square plus bx plus c equal to 0 is given by d is equal to b square minus 4ac, which has to be positive since a into c is negative. b square minus of a negative quantity, which will make it positive there. Hence the roots of the equation have to be real and distinct. We know that whenever the discriminant of a quadratic equation is positive, the roots of that equation has to be real and distinct. Therefore, the right option is real and distinct. So let's move on to the next question, question number 9. The foci of the ellipse x square by k square plus y square by 200 is equal to 1, and the hyperbola x square by 36 minus y square by 64 equal to minus 1 coincide. Then k square is first option 400, second option 100, third option 300, fourth option 500. The answer for it is B. We are given that the ellipse is x square by k square plus y square by 200 is equal to 1. That 200 we can write it as 10 root 2 square, and that equal to 1. So it's in the standard form x square by a square plus y square by b square equal to 1. The placement of the foci will depend on whether k square is greater than 200 or less than 200. So we shall now look at the given information about the hyperbola. We can see that the equation of the hyperbola is minus x square by 36 plus y square by 64 is equal to 1, and therefore a square is 64 and b square is equal to 36, that is comparing it to the standard form. So eccentricity of the hyperbola is 5 by 4. The formula is 1 plus b square by a square under root, and that is 5 by 4. So eccentricity as we see is 5 by 4, therefore AE has to be 10. Hence the coordinates of the hyperbola are 0, plus and minus 10. Foci of the hyperbola are 0, plus and minus 10. Since the foci of the hyperbola lie on the y-axis and foci of the ellipse and hyperbola coincide, therefore the major axis of the ellipse will be along the y-axis, that is the line x equal to 0, and the y coordinate of one focus will be 10. So for the ellipse 1, a square is 200, therefore 10 root 2 into e is equal to 10, where e is the eccentricity of the ellipse, and that's equal to 1 by root 2. Also b square is equal to k square, square of the semi minor axis of the ellipse. A square is equal to 10 root 2 square, which is equal to square of the semi major axis of the ellipse. Now k square is equal to 10 root 2 square into 1 minus e square, that is b square is equal to a square into 1 minus e square, which is equal to 200 minus 200 into e square, and that is equal to 200 minus 200 into half, which is equal to 100. Therefore the right option is 100. Let's move to the next question 10. The sum of the intercepts of the common tangent to the parabolas y square equal to 4x and x square equal to 4y on x and y axis is first option a equal to 2, second option b minus 2, third option 3, and fourth option 4. The answer is B. Let's explain how it goes. Given the parabolas are y square equal to 4x and x square equal to 4y, let us take a tangent to the first parabola. General form of this equation of the tangent to the first parabola is yt is equal to x plus at square if it is for the parabola y square equal to 4ax at the point at square comma 2at. So here at the point t comma t square, we can write the equation to be yt equal to x plus t square. Now substituting this x equal to yt minus t square from the first equation into the second equation x square equal to 4y, we get yt minus t square whole square is equal to 4y. That gives us a quadratic in y. The line has to become a tangent to the parabola. This quadratic in y must have equal roots, and therefore the discriminant has to be 0. And solving for t, we observe that t plus 1 has to be 0 because the other factor cannot be 0. So therefore t has to be minus 1. When we substitute t equal to minus 1 in that equation, yt is equal to x plus t square, we find that minus y is equal to x plus 1, that is x plus y is equal to minus 1. That becomes the common tangent, and clearly the x-intercept is minus 1 and the y-intercept is also minus 1. Therefore, the sum of the intercepts on the x and y axis is minus 2. Let's go to the second method. The given parabolas are y square equal to 4x and x square equal to 4y. We know that the equation of any tangent to the parabola y square equal to 4x is yt is equal to x plus at square. Now, the equation of the tangent to the parabola 1 will be yt equal to x plus t square, since a is 1 in this case, or rewriting the equation, it is in the form of x minus yt plus t square equal to 0. Equation of any tangent to the parabola 2 will be xt dash plus xt dash is equal to y plus t dash square. That is, the roles of x and y, as you can see in the equation 3, are interchanged. Therefore, we have t dash x minus y minus t dash square is equal to 0. But since we are looking for a common tangent, these two equations 3 and 4 have to be same, and therefore the ratios of the like coefficient should be equal. So t dash by 1 should be equal to minus 1 by minus t, and that is equal to minus of t dash square by t square. And from there we get tt dash is equal to 1 and t dash is equal to 1 by t. And finally, substituting that in the next equation, we get t dash square is equal to minus t, and that is 1 by t square is equal to minus t. That gives us t cube to be equal to minus 1. Therefore, t is equal to minus 1, and we will get back the same equation that we got. That is, the equation is x plus y plus 1 is equal to 0, and clearly the intercepts are minus 1 and minus 1. Therefore, the sum of the intercepts would be minus 1 plus of minus 1, which is equal to minus 2. Now, let's look at the shortcut method. From figure, it's clear that the intercepts of common tangent PQ on x and y axis will be negative numbers, and hence their sum will be negative number. Therefore, choice B is correct. Directly we can say that the sum of the intercepts will be minus 2, and that is in the option B. Option B is the right option. Let's move to the next question, question number 11. The number of all 3-digit numbers ABC for which A plus B plus C plus AB plus BC plus CA plus ABC is equal to 23, where ABC are distinct is first option 10, second option 18, third option 6, fourth option 14. The answer is the fourth option, that is 14. Let us see how it goes. You are given the condition that A plus B plus C plus AB plus BC plus CA plus ABC is equal to 23. Let's call that as equation 1, where ABC are distinct digits. Let's go this by case. Now, case 1, if ABC are all non-zero, the only possibility is ABC, all of them have to be 1, 2, 3. As you can see, the least values of ABC itself will give us this 1 plus 2 plus 3 plus 1 into 2 plus 2 into 3 plus 1 into 3 plus 1 into 2 into 3 has to be 23. So that is happening for the least positive values of ABC. And therefore, the number of such numbers, as you can see, is 3 factorial, because you can order ABC in 3 factorial ways. Therefore, we have 6 such numbers in this case 1. Case 2, when one of the digits is 0, the possibilities are 027 and 035. As you can see that 2 plus 7 plus 2 into 7 is equal to 23. The 0 terms are neglected here, and similarly 3 plus 5 plus 3 into 5 is also 23. So these two combinations are possible when 0 is allowed. So the number of such numbers with 0 allowed is 2 into 2p2 because the first digit cannot be filled by 0. So the first digit can be filled in two ways, and second and third digits can be filled in with the remaining two digits, that is 2 factorial ways. So that is for 0 to 1 combination, 0 to 7, the other combination 0 3 5, we have another 4. So 4 plus 4 totally 8, and hence putting together the case 1 and case 2, we have 6 plus 8, and that is equal to 14. Therefore the right option is 14. Let's move to the next question, question number 12. If f suffix r of n is equal to 1 power r plus 2 power r plus 3 power r so on up to n power r, then the sum of all values of positive integer n for which f3 of 2n divided by f2 of n is also an integer is first option 9, second option 8, third option 7, and fourth option 1. Now f3 of 2n by f2 of n, we want it to be a positive integer. But what is f3 of 2n? It is 1 cube plus 2 cube plus so on up to 2n cube. That's a numerator. Coming to the denominator, f2 of n is 1 square plus 2 square plus so on n square. We want that to be a positive integer. That we know that the sum of the cubes of first n natural numbers is n into n plus 1 whole square by 4. Now it is the sum of the cubes of first 2n natural numbers, therefore it is 2n into 2n plus 1 by 2 the whole square. What about 1 square plus 2 square plus so on n square? That we know from formula that it is n into n plus 1 into 2n plus 1 by 6. So and we want that to be a positive integer. So after simplification we get 6n into 2n plus 1 by n plus 1 to be a positive integer. Here n and n plus 1 have no common factor other than 1. Also 2n plus 1 by n plus 1 is equal to 1 plus n by n plus 1, which implies 2n plus 1 is not divisible by n plus 1. So 6 by n plus 1 has to be an integer, but the divisors of 6 are 1, 2, 3, 6, but n plus 1 cannot be 1 since n is a natural number. So n plus 1 has to be 2 or 3 or 6. So if n plus 1 is 2, n has to be 1. If n plus 1 is 3, n has to be 2. And if n plus 1 is equal to 6, n has to be 5. Therefore n has to be 1, 2 or 5. Therefore the sum of all such positive integers n has to be 1 plus 2 plus 5, and that is equal to 8. Therefore the right option is B, and it is 8. Let's move to the next question, question number 13. Let R be the set of all real numbers and f be a function from R to R such that it satisfies the functional equation f of x plus 2 into f of 2 minus x is equal to 14 for all x real numbers. Then f of 0 plus f of 2 is equal to first option 8, second option 7, third option 9, and fourth option 10. We are given that f of x plus 2 into f of 2 minus x is equal to 14. That is true for every x. What we wanted was f of 0 plus f of 2. So let's put x equal to 0 first. And we get f of 0 plus 2 into f of 2 is equal to 14. Now, we also want the individual values of f of 0 and f of 2. So if we can frame one more equation in f of 0 and f of 2, we can solve them simultaneously. So what we shall do is we put x equal to 2 and we get one more equation, f of 2 plus 4 into f of 0 is equal to 14. Now we have two simultaneous equations, f of 0 and f of 2. So solving them, we will get f of 0 to be equal to 2 and f of 2 to be equal to 6. And that gives us f of 0 plus f of 2 to be 8. The right option is A, that is 8. Let's move to the next question, question number 14. Integral of x power of x plus x square multiplied with 1 plus x into 1 plus log x plus x log x dx is first option x raised to the power 1 plus x square plus c, x raised to the power 1 plus x square plus c, third option x power x plus x square, and fourth option 1 plus x raised to the power x square plus c. The right option is C. Let us see how it goes. Put z is equal to x raised to x plus x square. Now dz by dx, we use the formula whenever we have z is equal to f of x raised to the power g of x, then dz by dx is equal to z into d by dx of x plus x square into the base function, that is d by dx of g of x into the base logarithm of the base function. So that gives us x raised to the power x plus x square plus d by dx of x plus x square into log x, that is x power x plus x square into, now the derivative of the inner function is x plus x square into 1 by x plus 1 plus 2x into log x. And grouping the terms, we observe that dz is equal to x raised to the power x plus x square and into 1 plus x into 1 plus log x plus x log x dx. Therefore, what we have in the integrand is simply dz. Therefore, the integral I will be equal to integral of dz, which is nothing but z plus c, the integration constant. What was z? But we have substituted z to be x power of x plus x square. Therefore, we get back this answer to be x power of x plus x square. Therefore, the right option is C. Let's move to the next question, question number 15. Let f of x be equal to 2 plus x power n a natural number, and f of 0 plus f dash of 0 plus f double dash of 0 by 2 factorial plus f triple dash of 0 by 3 factorial, so on up to n minus 1th derivative of f at 0 by n minus 1 factorial is equal to 242. Then the value of n is first option 5, second option 4, third option 6, and fourth option 7. Answer is A. Let's see how it goes. We are given that f of x is 2 plus x raised to the power n. That gives us f dash of x to be n into 2 plus x raised to the power n minus 1. F double dash of x will be n into n minus 1 into 2 plus x power n minus 2, so on and so forth. So we can rewrite this f double dash of x to be nc2 into 2 plus x raised to the power n minus 2. So f of 0 is 2 power n, f dash of 0 is nc1 into 2 power n minus 1, f double dash of 0 is nc2 into 2 power n minus 2 into 2 factorial. Continuing like this, f triple dash of 0 will be nc3 into 2 power n minus 3 into 3 factorial. Going on this way, n minus 1th derivative of f at 0 will be nc n minus 1 into 2 raised to the power n minus of n minus 1 into n minus 1 factorial. As you can see, the suffix in the binomial coefficient and is matching with 2 raised to n minus of that suffix. So we can see that f n minus 1th derivative at 0 will be nc n minus 1 into 2 raised to n minus of n minus 1, that makes it 2 power 1 into n minus 1 factorial. So substituting these values in the expansion that's required, that is f of 0 plus f dash of 0 by 1 factorial plus f double dash of 0 by 2 factorial, so on and so forth, n minus 1th derivative of f at 0 by n minus 1 factorial, we find that it is a binomial expansion 2 power n plus nc1 into 2 power n minus 1 plus nc2 into 2 power n minus 2, so on and so forth, nc n minus 1 into 2. Now, it is the binomial expansion of 2 plus 1 power n barring the last term, that is ncn into 2 power 0. So, that would be 1. So, 2 plus 1 power n minus that missing term, that is 1. Therefore, the answer is 3 power n minus 1 Now that is the expansion of what we have, but 3 power n minus 1 is given to be 242. So that gives us the value of n to be equal to 5. Hence, the option A is the right option. Question number 16. Let f be a function from 2, infinity to natural number set defined by f of x is equal to the least prime factor of bracket of x, where bracket x denotes the greatest integer not greater than x. Then the integral f of x dx from 2 to 6 is equal to first option 11, second option 12, third option 10, and fourth option 14. The answer is B. Let's see how it comes. We have seen that the function depends on where it takes an integer value. Now, when x lies between 2 to 3, bracket x value will be 2 and f of x will be the least prime factor of 2, which is equal to 2. When x lies between 3 to 4, bracket x is equal to 3 and f of x is the least prime factor of 3, that is equal to 3. So likewise, we have to branch out the domain 2 to 6 in the intervals 2 to 3, 3 to 4, 4 to 5, 5 to 6, where the function f of x behaves differently. So as you can observe, when x lies between 4 to 5, bracket x is 4 and f of x is the least prime factor of 4, and that is equal to 2. So f of x behaves as constant function 2 when x lies between 4 and 5. Similarly, as whenever x lies between 5 to 6, bracket x will be 5 and the least prime factor of 5 we know is equal to 5. Therefore, x behaves as, when x lies between 5 to 6, f of x behaves as constant function 5. Therefore, the integral turns out to be 2 dx from 2 to 3, 3 dx from 3 to 4, and 2 dx from 4 to 5, and 5 dx from 5 to 6, and therefore the integral will be 2 plus 3 plus 2 plus 5, and that's equal to 12. Therefore the right option is 12, and that is B. So let's move on to the next question, question number 17. In a triangle ABC, if sin A, sin B, sin C is equal to 1 minus cos A into cos B, and ABC are the lengths of the sides opposite to the angles capital A, capital B, capital C respectively, then which of the following is true? First option, A is equal to root 2B, second option, B is equal to root 2A, and third option, B is equal to root 2C, and fourth option, C is equal to root 2A. The answer is D. Let's see how it comes. We are given in the triangle 1 equal to cos A, cos B plus sin A, sin B, sin C. We know that sin C is less than or equal to 1, therefore the right hand side we can write it to be less than or equal to cos A, cos B plus sin A, sin B. Therefore 1 is less than or equal to cos of A minus B, which means that cos of A minus B is greater than or equal to 1. But we know that cos of any angle has to be less than or equal to 1. For cos of A minus B has to be equal to 1. So A minus B has to be 0, since A and B are angles of a triangle. Therefore this implies A is equal to B. That is, the triangle is turning out to be an isosceles triangle. And when you go back to the original equation and substitute A equal to B, we will find that sin C is equal to 1, and that implies C is equal to 90 degrees. Therefore the triangle is right-angled isosceles triangle with the hypotenuse as C, small c. Therefore C square is equal to either A square plus A square, or C square is equal to B square plus B square. Since small a and small b are one and the same, we can say therefore C is equal to A root 2, or C is equal to B times root 2. Therefore the right option is C is equal to A root 2, because you don't have C equal to B root 2 given in any one of the options. So right option is D. So let's move to the next question, question number 18. In a triangle ABC, alpha bar is equal to BC bar, and beta bar is equal to CA bar, and gamma bar is equal to AB bar. Then Modulus of alpha cross beta plus gamma cross alpha divided by modulus of beta cross gamma is first option 2, second option 1, third option 3, fourth option 4. We will show that it is the first option that is right. We are given that alpha plus beta plus gamma is null vector. So we will cross multiply both sides with alpha bar from the left. We can observe that alpha, beta, gamma taken in order form the sides of a triangle. Now, on simplification, we have alpha cross beta plus alpha cross gamma to be equal to 0, since we have taken the cross product with alpha on both sides. Now we get alpha cross beta to be equal to gamma cross alpha. Again, taking the cross product on both sides of the equation 1, that was alpha plus beta plus gamma equal to 0, with beta bar from the right, we get alpha cross beta plus gamma cross beta is equal to null vector. So that gives us alpha cross beta to be equal to beta cross gamma. Now alpha cross beta plus gamma cross alpha will become 2 times of beta cross gamma. Therefore the numerator is 2 times of beta cross gamma and a modulus, and the denominator we know is modulus of beta cross gamma. Therefore the answer would be 2. So the right option is 2. That is, answer is 2. A is the right option. Let's move on to the next question, question number 19. If alpha is the root of the equation x squared plus 4x plus 9 equals to 0, and f of x is equal to x plus 3 into x plus 4 into x plus 5 into x plus 6, then the value of f of alpha plus f of minus 1 is equal to, first option, minus 126, second option, minus 189, third option, minus 6, and fourth option, 120. The right option is C. Let's see how it goes. Alpha is the root of the equation. So when I substitute x equal to alpha, we get alpha square plus 4 alpha plus 9 equals to 0, which implies alpha square is minus 4 alpha minus 9. Now we wanted f of alpha plus f of minus 1. So now let's calculate what is f of alpha. F of alpha is alpha plus 3 into alpha plus 4 into alpha plus 5 into alpha plus 6. That makes it alpha square plus 7 alpha plus 12 into alpha square plus 11 alpha plus 30. That is, we have grouped the first two factors and the third and fourth factors separately. Now we substitute the value of alpha square from the equation 1, that is minus 4 alpha minus 9. Instead of alpha square, when you substitute minus 4 alpha minus 9, the equation becomes 3 alpha plus 3 into 7 alpha plus 21, and now again multiplying that, we get 21 into alpha square plus 84 alpha plus 63. Again we substitute alpha square as minus 4 alpha minus 9, and then we get the value of this as minus 126, because plus 84 alpha get cancelled there. Also f of minus 1 is equal to minus 1 plus 3 into minus 1 plus 4 into minus 1 plus 5 into minus 1 plus 6, and which is equal to 2 into 3 into 4 into 5, and that's equal to 120. Therefore f of alpha plus f of minus 1 turns out to be minus 126 plus 120, and that is equal to minus 6. Therefore the right option is C, and the answer is minus 6. So let's move on to the next question, question number 20. Which of the following statements is a tautology? First option, P or negation of P and negation of Q. Close the bracket. Second option, negation of Q and P and Q. Third option, P and P or Q. Fourth option, negation of Q and P and negation of P. Now the right option is A. We observe that we can use De Morgan's law in the statement, first statement, that is negation of P and negation of Q is equal to negation of P or negation of Q, that makes it Q. That is, the term in the bracket in the first expression becomes negation of P or Q. Substituting that, we have here P or negation of P or Q. Now, using associativity, we have P or negation of P or Q, and that P or negation of P is known to be always true. So we have a tautology distinction with another statement which we know that is always true because the first part is always true no matter what may be the truth value of the second part. That is, Q may be true or false, the disjunction will always be true, therefore it is a tautology. Now, we already have found that the first statement is a tautology. Now it is just a routine check to see whether the other ones are tautologies or not. Let us see. We find that the option B and turns out to be a contradiction always. And again, the option C is P, not a tautology. Option D is a contradiction because it is a distinction conjunction containing a contradiction statement, therefore it's going to be a contradiction. So anyway, the option A is the right option because it is the tautology. Let's move on to the next question, question number 21. The area bounded by the curves passing through the point 0, 1 and satisfying the condition that at any point x, y on the curve modulus of 2y dy by dx is equal to 1 is first option 2, second option 8 by 3, third option 2 by 3 and fourth option 4 by 3. The right option is B. Let us see how it comes. We are given that mod of 2y dy by dx is equal to 1. That gives us 2y dy by dx to be plus 1 or minus 1. Now cross multiplying and integrating both sides, it is in the variable separable form. So we have y squared is equal to plus r minus x plus an integration constant c. Now we shall determine this integration constant using the fact that the curves pass through the point 0, 1. So when I substitute x equal to 0 and y equal to 1 in that curve that we got as a solution of the differential equation, we get c equal to 1. Now we have two curves. Taking the plus sign, we get one curve. Taking minus sign, we get another curve. So what is that? Y square is equal to x plus 1 and y square is equal to minus of x minus 1. Now the required area will be 4 times of OBCO because you see that the graph is symmetric. Required area is symmetric about origin and also the x and y axis. So it's 4 times the area enclosed by this closed region OBCO, and we shall find this area by taking horizontal strips y ranging from 0 to 1. So we shall integrate x dy, and x on this curve is clearly 1 minus y square. So 1 minus y square has to be integrated within the limit 0 to 1. So what we get is, on simplification, the answer would be 8 by 3. Therefore, the right option is second option, that is 8 by 3. Let's move to the next question, question number 22. Let a be a positive quantity. Let x and y be lying between 0 to 1, x less than y, and x is equal to a plus ax square plus ax cube, so on up to infinity, the infinite GP. Y is equal to a plus ay square plus ay cube, so on up to infinity. Then the value of x plus y is first option 1 by 2, second option 2 by 3, third option 5 by 6, and fourth option 1. The right option is fourth option, that is D. Now we are given an infinite GP on the right hand side, x is equal to that, and we are also given that the common ratio would be x. Therefore the first term divided by 1 minus r, the common ratio, will be the sum of infinitely many terms of a GP when the common ratio is less than 1. Since we are given x to be less than 1, x can be taken as a by 1 minus x, which gives us x minus x squared is equal to a. From that, x squared minus x plus a has to be equal to 0. Similarly, we also have y squared minus y plus a equal to 0. So from these two, it's clear that both x and y satisfy a quadratic equation t squared minus t plus a equal to 0. And what we wanted was x plus y, that is sum of the roots. And therefore, sum of the roots we know for a quadratic equation ax squared plus bx plus c equal to 0 is minus b by a. Here, minus b would mean minus of minus 1 here, and by a is the coefficient of t squared, and that's equal to 1. So we get the sum of the roots to be 1. And therefore the right option is D. Let's move to the next question, question number 23. Equation of the plane passing through the point of intersection of the lines given in the symmetric form x minus 3 by 1 is equal to y minus 1 by 2 equal to z minus 2 by 3, and x minus 1 by 3 is equal to y minus 2 by 1 is equal to z minus 3 by 2, and at maximum distance from the origin is, first option, 4x plus 3y plus 5z equal to 50, second option, 3x plus 4y plus 5z equal to 49, third option, 5x plus 4y plus 3z is equal to 57, and fourth option, 7x plus 2y plus 4z is equal to 54. The answer is the first option, that is A. Let's see how that can be done. Now let's equate x minus 3 by 1 equal to y minus 1 by 2 equal to z minus 2 by 3 equal to lambda, lambda being the parameter. Similarly, the second equation also will take the parameter as mu. Therefore, the coordinates of any point on the line 1 will be lambda plus 3 plus comma 2 lambda plus 1 comma 3 lambda plus 2. Similarly, the coordinates of any point on the line 2 will be 3 mu plus 1, mu plus 2, comma 2 mu plus 3. If the lines are to intersect, now this lambda plus 3 should be equal to 3 mu plus 1, that is the x coordinate of both the general point on the line on the first line and the general point on the second line. The x coordinates and y coordinates and z coordinates must be same. So what we get is three equations. Lambda minus 3 mu equal to minus 2, 2 lambda minus mu is equal to 1. So from solving for lambda and mu, we get mu to be equal to 1 and lambda to be equal to 1. Now these values of mu and equal to 1 and lambda equal to 1 are consistent with the third equation also, which is obtained by equating 3 lambda plus 2 equal to 2 mu plus 3. Therefore here we will get that the point of intersection to be P, that is 4, 3, 5. The plane passing through this point P, 4, 3, 5 will be at maximum distance from origin if OP is perpendicular to the plane. Therefore, the drs of the line OP shall become drs of the normal to the plane. So therefore, the required equation of the plane is 4 into x minus 4 plus 3 into y minus 3 plus 5 into z minus 5 equal to 0. That is, we are making use of the formula, that is, if x1, y1, z1 is a point on the plane, and if ABC are the drs of the normal to the plane, then the equation of the plane can be taken as a into x minus x1 plus b into y minus y1 plus c into z minus z1 equal to 0. Therefore, from using that formula, we have, instead of x1, y1, z1, 4, 3, 5, instead of ABC, 4, 3, 5, those are the drs of the normal to the plane. Hence, we get the equation of the plane to be 4x plus 3y plus 5z minus 50 equal to 0. And for the right option is A. Let's move to the next question, question number 24. If f of x plus y is equal to f of x into f of y for all x and y real numbers, and f of x is equal to 1 plus x into g of x, comma, limit as x tends to 0, g of x is equal to 1, then f of x is continuous at, first option, x equal to 0 only, second option, all the points, third option, finitely many number of points only, and fourth option, at no point. The right option is answer B, that is, it is continuous everywhere. Let's see how it goes. Given f of x plus y is equal to f of x into f of y for all x and y real numbers, and also limit as x tends to 0, g of x is equal to 1. Let us consider an arbitrary point a, and now let us see if function f is continuous at the point a. So let's consider limit as x tends to a f of x. If it turns out to be f of a, then f of x would be continuous at that point. But then we can write this as limit as h tends to 0, f of a plus h. But what is f of a plus h? From the given functional equation, it is f of a into f of h. Therefore, it turns out to be f of a can be brought out to the limit, and we have f of a into limit as h tends to 0 f of h. But we already know that f of x is equal to 1 plus x into g of x. Therefore, we can write this as f of a into limit as h tends to 0, 1 plus h into g of h. And since limit as h tends to 0, g of h is equal to 1, we get in the bracket 1 plus 0 times 1. That is f of a into 1 plus 0 times 1. Therefore, we have the value of the function to be, the limit to be equal to f of a. Therefore, limit as x tends to a, f of x is equal to f of a. Hence, the function is continuous at a. And a was an arbitrary point. Hence, we can say that the function is continuous at all points. Therefore, the right option is B. Let's move to the next question, question number 25. If a function f from R to R be such that f of x plus y is equal to f of x plus f of y for all x and y real numbers, then the value of the determinant, first row f of 0, f of 1, f of minus 2, second row f of minus 1, f of 0, f of 3, third row f of 2, f of minus 3, minus of f of 0, where f of 1 is not equal to 0 is f of 1 into f of 2 into f of 3, that's the first option. Second option, minus of f of n into f of 2 into f of 3. Third option, f of 1 plus f of 2 plus f of 3. And fourth option is 0. The right option is 0. That is the fourth option. Let's see how it can be seen. F of x plus y is given to be equal to f of x plus f of y for all x and y real numbers. We'll put y equal to 0. Then we get f of x to be f of x plus f of 0, which implies that we can cancel out f of x and we get f of 0 to be equal to 0. Again, by putting y equal to minus x in the equation 1, we get 0 to be equal to, we get f of 0, that is 0 on the left hand side, and on the right hand side we get f of x plus f of minus x. That gives us f of x minus x to be equal to minus of f of x, which implies f of x is a knot function. From the equation 3, f of minus 1 is equal to minus of f of 1, f of minus 2 is equal to minus of f of 2, f of minus 3 is equal to minus of f of 3. Now, if you let a to be f of 1 and b to be f of 2 and c to be f of 3, the determinant turns out to be in the form of 0 a minus b minus a 0 c b minus c 0. Now, taking a minus 1 common from the first row, minus 1 common from the second row, and minus 1 common from the third row, we get minus 1 cube into the determinant, which is again delta. So delta is equal to minus delta, and that gives us 2 delta to be equal to 0, and in fact delta is 0. We can observe that it is the determinant of the skew symmetric matrix of order 3, and we know that determinant of a skew symmetric matrix of order 3 of any odd order is 0. Hence, we could have concluded at an early stage that this determinant is equal to 0. Therefore, the right option is option D. Let's move to the next question, question number 26. The line x plus y equal to 2 root 2 is shifted parallel to itself through a distance of 2 units in the sense of increasing of x value, and is then rotated by 15 degrees in clockwise direction about the point where the shifted line cuts the x-axis. The equation of the line in the new position is, first option, root 3x plus y minus 4 root 2 equal to 0. Second option, root 3x plus y minus 3 root 2 equal to 0. Third option, root 3x plus y minus 4 root 6 is equal to 0. And fourth option, x plus 3y minus 4 root 6 is equal to 0. The right option is the option C. And let us see how it comes. We are given the line x plus y equal to 2 root 2. We shall convert this into normal form. By dividing by root 2, we have it in the form of x cos alpha plus y sin alpha equal to p. And clearly that cos alpha and sin alpha are both equal to 1 by root 2. P will be 2, and that will be the perpendicular distance from origin to the line. Therefore, the line AB, as you can see in the figure, is the line in its old position. The line in, it is now slided to CD, as you can see from the figure. It's moved 2 units. Previously, the distance from origin to the line was 2 units. Now, it's been shifted by 2 more units. Therefore, the equation of the line CD shall become x by root 2 plus y by root 2 equal to p is now been made 2 plus 2. So, therefore, we have x plus y equal to 4 root 2. Therefore, the equation of CD is x plus y equal to 4 root 2. And you know that clearly the slope of the line CD is tan 135. Now, the line is rotated through an angle 15 degrees in the clockwise direction. Then it turns out to be CE line. And the point where this line is cutting the x-axis is 4 root 2 comma 0. So we need to find out the equation of CE. Clearly the angle CE, the line CE makes an angle 120, because now it is previously CD line was making an angle 135. After rotation through an angle 15 degrees in the clockwise direction, now the angle ECX turns out to 120. Therefore, the slope of CE is tan 120, which is equal to minus root 3. Hence, the equation of the line CE using the point slope form, we have root 3x plus y minus 4 root 6 is equal to 0. And it is the right option is and option C. Let's move to the next question, question number 27. For all values of theta, the line x minus 1 into cos theta plus y minus 2 into sin theta equal to 2 touches the circle which cuts on the y-axis an intercept of length. First option 4, second option 2, third option 2 root 3, and fourth option 1. The right option is the third option, that is C. Let us work out how it comes. We are given that the line is x minus 1 into cos theta plus y minus 2 into sin theta is equal to 2. Let us rewrite the equation as y minus 2 into sin theta is equal to 2 minus of x minus 1 into cos theta. That we can convert it further as y minus 2 equal to minus cot theta into x minus 1 plus 2 cosecant theta. Now, this is in the form of y minus 2 equal to some m into x minus 1 plus some constant into root over 1 plus m square. That is, it's in the form of, we know that y equal to mx plus a root 1 plus m square is a tangent to the circle x square plus y square equal to a square with slope m. Now, y minus 2 equal to m into x minus 2 plus a into root 1 plus m square would have been tangent to the circle x minus 1 whole square plus y minus 2 whole square equal to 2 square. So from the figure, the intercept of the circle 3 on the y-axis is AB is equal to 2 times AL, and that is equal to 2 root 3. Now that can also be obtained like this. What we wanted was the distance between A and B, that is, we shall find the points A and B where this circle meets the y-axis. That is, put x equal to 0 in the circle equation. We get then y minus 2 whole square equal to 3. So the y coordinates of the points A and B are 2 plus root 3 and 2 minus root 3. And the distance between them is clearly 2 root 3. Therefore, the y-intercept made by that circle which is touched by the given line is 2 root 3. Therefore, the right option is C. Let's move to the next question, question number 28. If cos x power 5 plus sin y power 7 plus cos z to the power 9 is equal to 3, then the value of cos inverse of cos x plus sin inverse of sin y plus cos inverse of cos z is, first option pi by 2, second option pi, third option 3 pi by 2, and fourth option 2 pi. The answer is the first option. Now we know that the maximum value of cos x power 5 is 1, the maximum value of sin y power 7 is also 1, cos z power 9 is also 1. So when can that equality to 3 hold good? When all of them are at their maximum, and all of them, because they're raised to odd powers, we get cos x has to be 1 and sin y has to be 1 and cos z is also 1. Therefore cos inverse of cos x would mean cos inverse of 1, which is 0. Sin inverse of sin y would mean sin inverse of 1, which is pi by 2. And cos inverse of cos z would mean cos inverse of 1 again, and that is equal to 0. Therefore the answer turns out to be 0 plus pi by 2 plus pi 0, and that is equal to pi by 2. Therefore the right option is A. Let's move to the next question, question number 29. A 7-digit number is formed at random using the digits 1, 2, 3. The probability that sum of the digits in the number formed is 10 is equal to, first option 42 by 2187, second option 77 by 2187, third option 35 by 2187, fourth option 55 by 2187. And the answer is the second option. Let us work out how it comes. Let's consider the sample space to be a set of all numbers that can be formed using the digits 1, 2, 3. Obviously repetitions are to be allowed. It is equal to 3 power 7, which is equal to 2187. Let E be the required event, that is 7-digit numbers using the digits 1, 2, 3 and having the sum to be equal to 10. Now we see that the possibilities are, first possibility is 3 2 and 5 1s. Second possibility is 3 2s and 4 1s. In the first case, the number of 7-digit numbers that can be formed is 7 factorial by 5 factorial. I divide by 5 factorial because there are 5 1s repeated. And in the second case, we have 3 numbers of one kind, 4 numbers of other kind. Therefore, the total possible numbers are 7 factorial by 3 factorial into 4 factorial. And therefore, the total turns out to be 77. That is 42 plus 35. That is 77. So that is N of E is 77. And the required probability is therefore N of E by N of S, and that is 77 by 2187, and the right option is B. Let's move to the next question, question number 30. The cost of running a car from A to B is rupees AV plus B by V, where V kilometers per hour is the average speed of the car. When the car travels at 30 kilometers per hour, the cost comes out to be rupees 75, while at 40 kilometers per hour average speed, the cost is rupees 65. Then the most economical speed of the car is, first option 50 kilometers per hour, second option 40 kilometers per hour, and third option 60 kilometers per hour, fourth option 45 kilometers per hour. So let's look at the solution. The answer is C. Let AB be equal to A. Let Y be the cost of running a car to cover a distance of A kilometers when average speed is V kilometers per hour. Then Y is equal to AV plus B by V. Given V is equal to 30, Y is equal to 75, and when V is equal to 40, Y is equal to 65. We have 75 equal to 30A plus B by 30. 65 is equal to 40A plus B by 40. So from the equations 2 and 3, it's clear that AB values are half and 1800. So now the equation Y turns out to be half V plus 1800 by V. So dy by dV is equal to half minus 1800 by V square. we got to minimize y. Y is now the equation which calculates the cost at an average speed of v. So it is turned out to be a function of v. So we got to minimize y as a function of v. So we have to find the critical points, find out the points where the derivative becomes 0, dy by dv is equal to 0, and that turns out to be v equal to 60. So at that point, that is v equal to 60, we find that d square y by dv square positive quantity, which means that at v equal to 60 kilometers per hour, y value will be minimum, and that is the cost would be minimum at v equal to 60 kilometers per hour. Hence, the right option is C.